Welcome to video lecture on testing of coarse aggregates. Coarse aggregate are the materials basically used as filler with binding material in the production of mortar and concrete. They are derived from igneous, sedimentary and metamorphic rocks or manufactured from blast furnace slag. Aggregates from the body of concrete reduce the shrinkage and affect economy. They occupy 70 to 80% of the volume and have considerable influence on the properties of concrete. It is therefore significantly important to obtain right type and quality of aggregates at the site. They should be clean, hard, strong, durable and graded in size to achieve utmost economy from the paste. The coarse aggregate form the matrix of concrete and the fine aggregate form the filler matrix between the coarse aggregate. Classification of aggregates. Aggregates may be classified into natural aggregates and artificial aggregates. So natural aggregates are obtained by crushing from quarries of igneous, sedimentary and metamorphic rocks. Gravels and sand reduced to their present size by natural agencies also fall in this category. The most widely used aggregate are from igneous origin. These aggregates require sieving, washing before they can be used in concrete. Broken bricks, blast furnace, slag and synthetic aggregates are artificial aggregates. Broken bricks known as brickbats are suitable for mass concreting. They are not used for reinforced concrete works. Blast furnace slag aggregate is obtained from slow cooling of slag followed by crushing. The dense and strong particles are obtained or used for making precast concrete products. Synthetic aggregates are produced by thermal processing material such as expanded clay and shale and used for making lightweight aggregate. According to the size, aggregates are classified as coarse aggregate, fine aggregate and all-in aggregate. Coarse aggregate, which is retained on 4.75 mm sieve, are identified as coarse. They are obtained by natural disintegration of artificial crushing of rocks. The maximum size of aggregate can be 80 mm. The size is governed by thickness of section, spacing of reinforcement, clear cover, mixing, handling and placing methods. All-in aggregate. Naturally available aggregates of different fractions of fine and coarse sizes are known as all-in aggregate. The deficiency of any particular fraction can be corrected for use in the mix, but they are not recommended for quality concrete. Fine aggregate. Aggregate passing through 4.75 mm sieve are defined as fine. They may be natural sand deposit by rivers or crushed stone type. Aggregates are classified based on their shapes such as round, irregular, angular and flaky obtained by crushing stones. Rounded aggregates. These are generally obtained from river or seashore and produce minimum voids in the concrete. They have minimum ratio of surface area to the volume and the cement paste required is minimum. Poor interlocking bond makes it unsuitable for high strength concrete and pavements. Irregular aggregate. They have voids about 36% and require more cement paste as compared to rounded aggregate. Because of irregularity in shape, they develop good bond and suitable for making ordinary concrete. Angular aggregate. They have sharp, angular and rough particles having maximum voids of 40%. The angular aggregate provide very good bond than earlier two. The most suitable for high strength concrete and pavements. The requirement of cement paste is relatively more. Flaky. They are sometimes wrongly called as elongated aggregate. However, both of these influence the concrete properties adversely. The least lateral dimension of flaky aggregate should be less than 0.6 times the mean dimension. They adversely affect durability and are restricted to maximum of 15% in the mass. Aggregates are classified as normal weight, heavy weight, lightweight aggregate depending on the weight and specific gravity as given in the table. Aggregate, normal weight, heavy weight, lightweight. Specific gravity for normal weight aggregate is 2.5 to 2.7 and unit weight of 23-26 kN per meter cube and bulk density of 1522 to 1680. Similarly, heavy weight having specific gravity of 2.8 to 2.9, unit weight of 25 to 29 kN per meter cube and bulk density of 2080. Then testing of coarse aggregate. Following are the important tests to be conducted to explore its properties or sieve analysis test, crushing value test, impact value test, abrasion value test, flakiness index test and elongation index test. Sieve analysis. The test is conducted as per IS 23A6 1963 Part 1. Sample of coarse aggregate as required to be tested are taken in sufficient quantities as per the given table. The minimum weight of the sample for the test should be as follows. The minimum size present in substantial proportion, corresponding minimum weight of sample to be taken for sieving. If the size of the sample will be 25 mm, the amount of weight to be taken for sieving is 5 kg. Similarly, according to the size of the proportion present in the aggregate, the minimum weight of sample shall be taken here from the table. The air-dried sample is placed on set of specific sieves with largest size on the top. The set of sieve is shaked for 2 minutes. Arrangement of sieve for different types of aggregate is shown. For coarse aggregate, the sieves shall be arranged as 40 mm, 60 mm, 40 mm, 20 mm, 16 mm, 10 mm, 4.75 and 2.36. The shaking shall be done with a varied motion, backward and forward, left to right, circular, clockwise, anti-clockwise, with frequent jarring, so that the material is kept moving over the sieving surface frequently with changing directions. Material should not be forced by hand. Any lumps of fine material, if present, may be broken by the gentle pressure with fingers on the side of the sieve. Light brushing will be done. On completion of the sieving, the material is retained on each sieve together with any material cleaned from the mesh shall be weighed. The result shall be calculated and reported as cumulative percentage by weight of total sample passing of each sieve to the nearest whole number. A curve is plotted with sieve sizes and abscisses on a graph and a percentage of aggregate passing as ordinate. From this graph, a relative amount of various sizes of aggregates can readily be compared. The graph is shown here. So on the x-axis it is a logarithmic graph, a semi-logarithmic graph, and x-axis the sieve sizes are marked in logarithmic scale, and percentage y-axis the percentage passing in an ordinary graph. It shows the curve obtained from by plotting the percentage finer with the sieve sizes will be called as a grading curve, and it is used to obtain the comparison with the standard one as per IS 383. So in this, the table shows the percentage passing of single size aggregate and percentage passing for graded aggregate according to the sieve size. From the grading curve grading curve obtained, it can be compared with whether the aggregate is single size aggregate or graded aggregate. Crushing value test is conducted as per IS 2386 part 4. The material for the test should consist of aggregate passing 12.5 mm sieve and retained on 10 mm sieve. The aggregate is tested in a surface dry condition. The weight of material comprising the test sample is determined as A. The cylinder of the test apparatus is positioned on the base plate. The test sample is added in 1/3, each being subjected to 25 strokes from the tamping rod. The surface of aggregate is carefully level and plunger is inserted so that it rests horizontally on the surface. The apparatus with test sample and plunger in position is placed between the platens of the testing machine and loaded in an uniform rate as possible, so that the total load is reached in 10 minutes. The total load should be 400 kN. The load is released and the whole of the material is removed from the cylinder and is sieved on 2.36 mm sieve. The fraction passing the sieve is weighed. The ratio of weight of fines formed to the total sample weight in each test is expressed as percentage and expressed as aggregate crushing value. Aggregate crushing value equal to B by A into 100, where B is the weight of fraction passing the appropriate sieve and A is weight of dry sample. The image shows here the crushing value mold. It consists of a metal measure and a metal cylinder with a plunger and a base plate. The aggregate impact value test. It is conducted as per IS 2386 part 4. The aggregate impact value gives a relative measure of resistance of aggregate to a sudden shock or impact, in which some aggregate differs from its resistance to a slow compressive load. The test sample consists of aggregate, the whole of which passes a 12.5 mm sieve and is retained on 10 mm sieve. The aggregate comprising the test sample is dried in a oven for a period of 4 hours at a temperature of 100 to 110 degrees centigrade and cooled. The measure is filled about 1/3 full with aggregate and tamped with 25 strokes of the rounded end of the tamping rod. A further quantity of aggregate is added and further tamping of 25 strokes is given. The measure is finally filled to overflowing, tamping 25 times, and surplus aggregate is struck off using tamping rod as straight edge. The net weight of aggregate in the measure is determined to the nearest gram, and it may be taken as weight A. A cup 102 mm internal diameter and 50 mm deep is fixed firmly in position on the base of the machine, and the whole of the sample is placed in it and compacted by single tamping of 25 strokes. The hammer is raised until its lower face is 380 mm above the upper surface of the aggregate in the cup and allowed to fall freely on the aggregate. The test sample is subjected to a total of 15 such blows, each being delivered at an interval of not less than 1 second. The crushed aggregate is then removed from the cup and the whole of it is sieved on 2.36 mm IS sieve until no further significant amount passes in 1 minute. The fraction passes the sieve is weighed to an accuracy of 0.1 gram and it may be taken as weight B. The fraction retained on sieve is also weighed as weight C, and if the total weight B plus C is less than the initial weight A by more than 1 gram, the result is discarded and a fresh test is made. 2 tests are made, and the ratio of the weight of fines formed to the total sample of weight in each test are expressed as percentage recorded to the first decimal place. The aggregate impact value equal to B by A into 100. B is the fraction passing 2.36 mm sieve and A is oval dried sample. Aggregate aberration value. It is conducted as per IS 2386 part 4. The test sample consists of clean aggregate dried in an oven at 105 to 110 degrees centigrade to substantially constant weight. The test sample and the abrasive charge is placed in the Los Angeles aberration testing machine, and the machine is rotated at a speed of 20 to 33 revolutions per minute. For gradings A, B, C and D, the machine is rotated for 500 revolutions. For gradings E, F, G, it is rotated for 1000 revolutions. The samples which is to be collected for different grades are also given in the table. The machine is so driven and so counterbalanced so as to maintain substantially uniform peripheral speed. At the completion of the test, the material is discarded from the machine and a preliminary separation of sample is made, which is coarser than 1.7 mm. The finer portion is then sieved on a 1.7 mm sieve. The material coarser than 1.7 mm sieve is washed dried in an oven at 105 to 110 degrees centigrade to a substantially constant weight and accurately weighed to the nearest gram. The difference between original and final weight of the test sample expressed as percentage of original weight of test sample gives the percentage of wear. Flakiness and elongation index. It is conducted as per IS 2386 part 1. For flakiness and elongation index, sufficient quantity of aggregate is taken so as to provide at least 200 pieces of any fraction to be used. The sample is sieved through IS sieve as per the given table. For determining the flakiness index, the aggregates retained on the sieves are separated. Now each aggregate piece is passed through the corresponding slot in the thickness gauge. The image shown here is the thickness gauge, and the flakiness index is found by the weight of aggregate passing through the slot of thickness gauge by total weight of the sample into 100. For determining the elongation index, the aggregate are sieved through the corresponding sieves. The aggregate retained on each sieves are separated. Then each aggregate piece is passed through the corresponding slot of length gauge. Then the elongation index will be found out equal to weight of aggregate retained on length gauge divided by total weight of aggregate into 100. The image shows here is the length gauge. Thanks for watching.